Well, good morning. I'm Pat Ryan with the NASA Public Affairs Office here at the Johnson Space Center in Houston. We're in the International Space Station Flight Control Room. Joining me is Brion Au, who is a PLUTO flight controller. What is a PLUTO flight controller, Brion?
It's an acronym. It stands for Plug-in Port Utilization Officer. And we provide plug-in services to the crew to make sure the equipment that they use on a day-to-day basis is compatible with other equipment, and we contrive a plan on where to plug that equipment in. And in addition to that, we provide IT support for the crew, the network support for an operations local area network that the crew uses to get their morning messages, procedures, their daily plan and what they're supposed to do for the day. And that's also how they contact home. We've got an IP phone that they can use through the network that they can call anybody in the world.
You're supporting pretty much everything that goes on board the station that
operations,
way.
Yes.
All operations.
Yes. We're not doing commanding of the ship, just the operations support.
So that's who we are, and we're ready to try to answer your questions. Go ahead.
So hi, I'm Cole Nelson from Stonewich High School, and I was wondering what are some of your favorite and least favorite parts about working for NASA?
Probably the most favorite part is it's the awesome people that we've got working here. We've got some incredibly smart folks, and the teamwork that goes into making spaceflight happen is just amazing. The least favorite of all my activities here is catching up all the paperwork. We have to document what we do. That's how we carry forward the solutions to problems we've solved, and also carry forward the information for the future generations to use. So yeah, that paperwork's necessary.
Go ahead, next.
Thank you.
I'm from Kingston High School. I want to know if watching a rocket launch is very stressful.
No, not really. No more stressful than, let's say, taking your driving test. First of all, you have to learn, about your mission, and we study each mission, each phase of that flight in great detail. We practice it. We go through simulations, sims as we call them. We review the results of those sims to get better. It's kind of a mea culpa when you review afterwards and realize what you did right, what you did wrong. And this way you get it right. And then when you actually get to flying the mission or watching a rocket launch, it's just a matter of fact. So that's when you go to take your driver's test. Now you got to show the evaluator that you did a good job in learning what you were supposed to do.
More High School, and my question is, how often do you face emergencies, and what are the most common types of emergencies?
Well, thankfully we don't encounter that many emergencies. The most frequent that we see on the space station itself are those involving smoke detection. The smoke detectors are devices. You have to pull air through them so they can detect the smoke particles. And every once in a while, we'll get thankfully to now, a false alarm. But when they do sound the alarm, everybody stops what they're doing here in Mission Control, and we help guide the crew through the isolating where the signal is being enunciated from, which module the alarm is going off in. And we also have information ready for the crew to help them work through any extinguishing actions, any actions they have to take to put out a fire if it were actual. And we also have information ready for the crew so that if they have to evacuate the station, they can do that safely.
But as you say, it's not come to that, although occasionally fire alarms do go off. Those alarms go off because some sort of particle has come through them, and other particles that are not part of smoke can sometimes set them off, and that's usually what we see.
Dust, and then human skin is the real tiny flakes. In micro-G, they tend to float. They don't settle to the floor, and as the air current pulls those through the smoke detector, they sound a false alarm.
Yeah. Okay.
Thank you.
Hi, I'm Riley Nelson from Snohomish High School, and my question is, in your opinion, what is the biggest challenge facing the future of American manned spaceflight?
Oh, Riley, unfortunately, I don't think that's inside the space program. We've got a political and socio-economic issue that the Space Administration is facing on first of all, identifying a mission for NASA, and then as we go about trying to satisfy that mission, it's working to inform the legislators that it's going to cost a little bit more than we thought because the problems are greater than we imagined. So it's the funding. Now the technical stuff, we've got really smart engineers, some of the brightest people in the world, and we also have a knowledge bank of universities that we pose problems to and let them work out issues. So the technical stuff is actually easy. It's the funding for NASA that is the biggest problem, the biggest hurdle.
Okay.
Hi, I'm Sarah Aldrich from Lynn Ritz-Hill High School, and my question is, where do you see PLUTO going in the future? Are there any changes being made to it, or?
Oh, Sarah, we're actually one of the youngest flight controller disciplines here at NASA. We started just a few years ago when we migrated a network over that used to fly in the shuttle. It was a little coax network, and it was strictly contained on board the station. We'd get the crew their procedures and a morning message, and that was about it. Now the crew can dial anywhere around the world. We've got a huge movie library that is part of the network now. We're looking for more and more ways to utilize the IT resources to offload the crews so that we can actually do some of their work down here on the ground. So the PLUTOs are looking forward to actually migrating to the long duration missions through Orion and the other deep space missions. Probably one of the biggest problems that we're faced with right now is increasing crew autonomy. So we're looking at trying to enhance the programs that the crews use as a knowledge base so that they can become more autonomous to themselves. They don't rely like the station guys do on mission control quite so much. The more intelligence that they have, tools that are computer-based to help them work through problems without Earth's call coming that's 20 minutes away to solve their problems, it is one of the big things we're studying right now.
Yeah, what you're referring to is that on future missions, when we go to Mars, for example, it takes about 20 minutes for a voice message to get from Earth to Mars. So if Houston called them, it would take 20 minutes to get there, and then when they had an answer, it would take 20 more minutes to get back. So crews can't have to rely on people on the ground to do things for them right away. They have to become more self-sufficient in the future.
Yes, especially in emergencies, they need answers now. So we'll have tools developed to help through that problem. We're also looking into different ways of helping them for their experiment problems. If something is not going exactly right, they can hit up a knowledge base that will help them resolve the issue and then get the experiment back on track.
Okay, next question.
All right, thank you.
Hello, my name is Hudo from Inglemoor High School, and if my understanding of PLUTO is correct, then I have two different questions. The first one is, how is wiring in space different from wire? The second question is, what kind of training, like electrical engineering, do you need to do your job?
we do have numerous electrical engineers that are PLUTOs. We also have computer engineers and computer science majors that are part of the PLUTO team, and we kind of teach each other the side that we're not as strong in, or where our undergrad work was not. The wiring on board the space station it's direct current, so it's very simple circuits. It's no different. It follows a very, very strict code, to use a term that they use in the construction industries, so that it's done correctly and it's verified, and it's very forgiving to faults that may occur. We try to keep it as safe as we can for the crew. The big problem that we see with electrical current in microgravity is its ability to spark. And if you understand a threshold of the voltage and the current that is passing through a wire, at a certain level, it will create a spark. In space, that's not good, because those sparks usually contain very small particles of molten metal. And with in micro G, that actually could float and get into the crew's eyes. And because there's a lack of convection cooling, the metal's going to stay hotter longer. So it has the potential to burn the crew members. So we have to understand that and put in countermeasures to help the crew stay safe for when they're connecting, disconnecting, make sure you de-energize circuits. And there's some common sense stuff like that the crew practices before they go. And we also include messages inside the procedures when they're connecting, disconnecting stuff, to make sure that they follow the right steps to do that safely.
Okay.
Thank you.
Hello, my name is Ben Beck from Newport High School, and so I'm wondering if will there be less astronauts in space in the future as wireless instrumentation system technology grows in the future?
No, we've got several projects right now that utilize the wireless instrumentation system even to go outside the station now. We've got the current system is two-phase. We have an internal section and an external section that measures vibrations through the station. We're extending that network now to include EVAs. When the crew actually goes outside EVA, we can talk to them wireless. We can see their video that comes back in wireless. So actually what that's going to do is make us able to assist the crew in more ways from the ground versus cutting down the crew. To get the crew more engaged in different projects, we're using our technology to offload the crew so that they can spend more time doing the actual science and other actions that they need to on board the station.
Okay, thank you.
Hi, I'm Jacob from Butte Harbor High School, and my questions were, what is being done to standardize data and electrical connections with the international different devices? And my second question is, what specific challenges do you face with Earth to space communications versus long-range Earth communications?
The connectors and everything that we use actually are a standard. NASA has a document that controls each connector, how it is used, which one is used for what purpose, and the voltage. And because we're actually running two systems. We've got a 28-volt system that operates, and we have a 120-volt DC system that operates. So those are well defined. There's an interface control document, that's its title, that specify what type of connectors and even the manufacturers and where you can get these to make sure that things do connect. Now for the communications question, even today we have about a 2 to 2.5 second delay in the time it takes communications to reach from here, let's say at Mission Control in Houston, up to the TDRS satellites and then over to the space station. So even with that delay, it does cause problems. Some of the problems we encounter as PLUTOs, with the crew using software that may be communicating via this TDRS network to the ground through the KU system, that the software doesn't tolerate those delays. So we've got to work through a delay tolerant network issue. The network is delay tolerant. We know that, and that's the way it was developed. But some of the software that we're actually using does not tolerate that 2.5 second delay from when it sends a call for data out and it needs an answer back. Usually those are in milliseconds.
So do you have to rewrite the software?
We've actually rewritten software. We've got a team that does that. We've also created hardware that will literally, and I don't want to use the term fake out, but it accounts for that time delay, and the software doesn't crash because of that delay. So yeah, we have both software and hardware solutions to those problems.
All right, thanks a lot.
Hi, I'm Nick McGill from Bellevue High School. What means of propulsion are you currently considering using on the manned mission to Mars?
Well, right now, to get off the Earth, we have to use chemical rockets. There's several different schools of thought on, which rocket engine should run on kerosene or liquid hydrogen and liquid oxygen and others, or even alcohol. But we do have several different ion thrusters that folks have been working on. And we just need to get funding so that we can push to get much larger ion thrusters. And they're actually large enough to propel something from, let's say, a high Earth orbit out to Mars and then actually back. So it's a combination, chemical and then ion thrusters.
Thank you. My name is Eric Peterson. I am from Charles Wright Academy, and I wanted to know, what is the most stressful mission you've participated in?
Oh, Eric, let's see. Well, Plutos really don't get involved in the things that go boom. So actually, the most stressful, I'll kind of break that down into two different ways. The complexity of the 12A and the 12A.1 mission back in I think March of 2006 were just a ton of work for the Plutos. The crew was the shuttle mission was taking up parts of the truss, the solar arrays, and as they reconfigured and attached the new arrays, the power buses were actually being reconfigured. So in order to make sure that the crew had their onboard services, literally the power that they needed to conduct all these activities, we had to come up with a plan to move things from one bus to another in a different power channel, and then we literally managed that on an EVA by EVA basis when the crew was out, literally switching these connections.
Right.
So we had to keep the flight director and appraised of what services he did have and what he didn't have. The perhaps one of the most fatiguing missions, a different word there, was the 1J mission, where the crew took up the Japanese Kibo module. That mission was 16 days long, and we had sliding shifts from launch until they landed. And we extended that mission by another couple of days because we had to put in a fourth EVA. And at the end of those 16 days, with not being able to stay on the same sleep schedule, I was both physically and mentally just fatigued. That was a long time to spend 9 hours a shift every day coming into mission control and then making sure nothing went wrong. So yeah, that two different kind of ways, but yeah, those are my most memorable missions right now.
Lake Stevens High School, and my question was, what are the greatest dangers that you have faced in missions, And what are the greatest dangers NASA now faces in regard to space travel?
Oh, let's see. For mission controllers, my greatest danger is just getting in traffic and getting to work.
Yeah, driving.
Yes. Yeah. The crew, unfortunately, is faced with a very hostile and an unforgiving environment out in space. That's why they have the controllers down here on the ground looking over their shoulder. We actually do more to operate the space station than the crew actually does. We keep track of all of the environmental controls, the power generation, the thermal rejection, the heat that's generated by all the electric equipment that's used, and then all the stuff that the crew uses to accomplish their tasks, and even monitoring some of the experiments, which could be potentially very dangerous if they ran unchecked or whatever. And because of that, again, this go back to that crew autonomy stuff. We're trying to work on programs that will help the crew to operate just among themselves instead of relying so much on MCC. So we're developing a lot of those autonomy programs, and we actually do experiments with the crew where we simulate not being able to talk to Earth except maybe once 5 minutes for every hour on these experiment type days. So it's pretty neat to see and get feedback from the crew on how things did or didn't work, so that we can tailor our operations here on the ground to help them better.
Clearly, the environment for them there is dangerous, but there are so many systems that are built into this vehicle, along with the backup for control
Yes.
that comes down here, that on a day-to-day basis, as they go about their jobs, it's really not an issue. But the crew members are also very well trained to respond to anything that does happen.
Yes, they are well versed in the emergency response to all of the systems on board. And as a matter of fact, the controllers here on the ground most often will know when something is going wrong before the crew will, and that's why we're here. And for every person that you see sitting in mission control on the TV screen, there's usually sometimes 2, 3, or even 4 people sitting in what we call the back room, supporting the lead controller in the flight control room here with the flight director. So there's definitely multiple sets of eyes watching over the crew and making sure that the vehicle is safe for them.
Okay, I think, do we have time for one more? No, I think we don't have time for one more.
Okay.
I'm told. Brion, thanks very much. It's some really interesting information, and I hope that you guys in Washington got the answers that you were looking for, and we sure appreciate the questions. Thank you very much.
Thank you, everybody. Those were really awesome questions.